Well, to finish up our section on dividing polynomials, we're going to look at a couple of theorems. This first one I don't think we'll use too frequently, but it is quite interesting. If the polynomial f of x is divided by x minus some constant, the remainder is f of that constant. That is pretty fascinating. Let's do an example. Given this polynomial function, use the remainder theorem to find f of 4. Yes, it would be easier to simply plug 4 into this function, but we're just going to verify that the remainder theorem works correctly. So we're going to divide this by x minus 4, and whatever the remainder is would be f of 4. So we're going to do synthetic division, so we're going to put a 4 in the cup, and then put all the coefficients of this polynomial, 2, negative 11, 7, negative 5, all on the same row. So we bring down the 2, and 4 times 2 is 8. Add the column and we get a negative 3. 4 times negative 3 is negative 12, and we add the columns, and so negative 7, or negative 12 plus 7, which would be a negative 5. And then 4 times negative 5 is negative 20. And add this together and we get negative 25. So this is the remainder, which is equal to f of 4. I will let you plug in, maybe I'll go ahead and do it. What is 4 cubed? What we're doing is we're going to find f of 4 by plugging it in this time. 4 cubed is 4 times 4 times 4, 16, 64. So 2 times 64 minus 11 times 4 squared. 4 squared is 16. Plus 7 times 4 minus 5. So that's 128 minus 176, because 11 times 16 is 176, plus 28 minus 5. So let's see what we get when we add the positives. 128 and 28 would be 156. Let's see. That is not working out. I plugged in a 4, let me make sure I did it correctly. Let me go through all these again. That's an 8, that would be negative 3. Negative 12 would be negative 5. Negative 20, negative 25. All right, so then f of 4 is 2 times 64, 128, minus 11 times 4 squared, which is 16. Yep. Plus 7 times 4 is 28, minus 5. So 128, that's 156. Let's see, 156. And then what do negative 176 and negative 5 add up to? That is negative 181. And let's see, 56, 66, 76. Indeed it is negative 25. Thought I made an arithmetic mistake there first, but f of 4, by plugging it in, we discovered that indeed it is negative 25. So as I mentioned, you might have some homework problems where you have to use the remainder theorem, but I don't typically put this on an exam. And let's do one more. Remainder theorem. Okay, so we're going to do the same thing. We're going to do a division. So if I want to find g of negative 4, that means I've got to put, I'm essentially going to divide by x plus 4. So I'm going to put a negative 4 in the cup. All right, remember here we were getting f of 4, so we put 4 in the cup. Here's g of negative 4. We're going to put negative 4 in the cup, and then we're going to put all these coefficients next to it. 3, 4, negative 5, 3. Okay, so we bring the 3 down. Negative 4 times 3 is negative 12, and negative 12 and 4 give us negative 8. Repeat. Negative 4 times negative 8 is 32. 32 and negative 5, positive 27. Okay, negative 4 times 27 would be 108 in the negative. And then adding 3 to that would give us negative 105. So that's the remainder. And the claim is this should be equal to g of negative 4, which will be 3 times, well, I'll go ahead and write it, negative 4 cubed plus 4 times negative 4 squared minus 5 times negative 4 plus 3. Let's simplify that. That's going to be 3 times negative 64 plus 4 times 16 plus 20 plus 3. 64, this would be 192 negative 192. This would be 1632 64 plus 23, and this would be, let's see, 64, 74, 84, 87. So negative 192 plus a positive 87 is a negative 105, which is exactly what we expected. G of negative 4 is negative 105. Once again, that's a remainder theorem that you may have a couple of homework problems on, but I will not put the remainder theorem on an exam. But you will probably see that again in a future class, perhaps even calculus. All right, we have one more theorem, and I'm sure you know this theorem already, but you may not know it by its name. The factor theorem. And this is going to help us factor polynomials. Let f of x be a polynomial. Well, if that's the case, then f of c equals 0, if and only if what? Well, by definition, that means that c would be a 0, a root, an x-intercept. If and only if it's a 0, x minus c is a factor of f. And that makes sense. I mean, and we'll see how it makes sense in this example. All right, here we have a third degree polynomial. Use the factor theorem to determine if x minus 3 divides f of x. In other words, that means determine if it's a factor. If you were to divide it, would you get a 0 remainder? Well, by the factor theorem, all we have to do is plug in 3. Because look, if x minus 3 were a factor, that means it's multiplied by all the rest of the other factors. But what do you get if you plug x equal 3 into this factor? You get a 0, which would 0 the whole thing out. So let's see what f of 3 is. F of 3 is 2 times 3 cubed minus 3 times 3 squared minus 11 times 3 plus 6. 3 cubed is 27 times 2 is 54. 3 squared is 9 times 3 is 27, so times negative 3 would be negative 27 minus 33 plus 6. So I like to add the positives and negatives together. The positives are 54 and 6, so that gives us 60. And the negatives add up to negative 60. So that means, based upon this, we know that x minus 3 is a factor. So if we were to do synthetic division, that would be the first step and the toughest step in factoring this. When I look at this polynomial, I don't know how to factor an x cubed that looks like this. Factoring by grouping will not work in this case. So once we divide it by x minus 3, we're going to get an x squared polynomial that will be much easier for us to factor. Worst case is you'd use the quadratic formula to factor the quadratic that remained. So that's the factor theorem.